everyone, these are the triangles guided notes. Now I just want to say this topic is absolutely best learned through discovery. If I'm just telling you these answers, you're not going to retain it as well as if you try it out before the answers are given, and I will tell you when you should try it out. You will need a ruler and a protractor and perhaps even some scratch paper to complete these guided notes accurately in a way that is discovery based. Let's get started. An equilateral triangle is a triangle with 3 equal side lengths. And then I want you to sketch a picture of an equilateral triangle. Now these are just sketches. It's not going to be perfect, but it can give you an idea of what it will look like. An isosceles triangle is a triangle with only 2 equal side lengths. And then sketch your picture. So you notice that this side length and this side length are equal. And there's only 2 equal side lengths. A scalene triangle is a triangle with no equal side lengths, something like this, where all side lengths are different lengths. An acute triangle is a triangle with 3 acute angles. Remember that acute means less than 90. 90 degrees looks like a corner. So 3 angles that are less than 90 degrees. A right triangle is a triangle with 1 right angle. So again, a right angle is what maybe looks like a corner. So this is a triangle with 1 right angle. So that is a right triangle. An obtuse triangle is a triangle with 1 obtuse angle. So obtuse means greater than 90. This is the obtuse angle right here in this obtuse triangle. Okay, this page is an example of something I really want you to do before I give you the answer. So it says, draw the following geometric figures given the conditions. If not possible, write not possible. So I want you to try and draw a triangle with 2 obtuse angles. Hit pause and try that now. A triangle with 2 obtuse angles is not possible. Now try a quadrilateral, which means a shape with 4 sides with 2 obtuse angles. Hit pause and try that now. This is an example of a quadrilateral with 2 obtuse angles. There's one right there and one right there, and this has 4 sides. Now I want you to try a right isosceles triangle. Hit pause and try drawing a right isosceles triangle. A right isosceles triangle is possible. Remember, a right triangle has a right angle, and isosceles means that 2 lines are the same length. Now try a right obtuse triangle. Hit pause and try drawing a right obtuse triangle. A right obtuse triangle is not possible. Now we are going to try drawing a quadrilateral with 4 acute angles. Hit pause and try drawing a shape with 4 sides where all of the angles are acute. Okay, drawing a quadrilateral with 4 acute angles is not possible. Now let's try a quadrilateral with 2 right angles, or you could even do more than 2 right angles. Hit pause and try drawing a quadrilateral with at least 2 right angles. This is a quadrilateral with 2 right angles. Now I want you to try drawing a acute equilateral triangle. So a triangle with all 3 equal side lengths where they are all acute, meaning less than 90 degrees. Hit pause and try drawing an acute equilateral triangle. This is an acute equilateral triangle. All side lengths are the same length and all angles are acute or less than 90 degrees. Last one, try drawing an obtuse equilateral triangle. Hit pause and try that now. An obtuse equilateral triangle is not possible. Side lengths. Can any 3 side lengths form a triangle? For example, if we have 3 lines with the lengths of 1 inch, 2 inches, and 20 inches, could they form a triangle? I want you to hit pause and try drawing a triangle with those side lengths, 1, 2, and 20 inches. You should have noticed that it is not possible. 20 inches is way too long. If I have 20 inches and then I have one side of 1 and one side of 2, there's no way that I can get those to connect. What about side lengths of 2 centimeters, 4 centimeters, and 6 centimeters? Again, I want you to hit pause and try constructing a triangle with these side lengths. You should have noticed that it is not possible to construct a triangle with the side lengths 2, 4, and 6. Now try the side lengths 3 centimeters, 4 centimeters, and 4 centimeters. Hit pause and try constructing a triangle using those side lengths. Could you construct a triangle? Yes, you should have been able to construct a triangle using 4, 4, and 3. Now try the side lengths of 1, 5, and 10. Could you construct a triangle? Hit pause and try constructing a triangle. You should have noticed that it is not possible to construct a triangle using the side lengths 1, 5, and 10. Okay, we're going to keep going with trying to construct triangles. Hit pause and try making one out of 2, 2, and 6. You should have realized that it is not possible to make a triangle out of 2, 2, and 6. Now I want you to try 2 and 2 and 4. Could you form a triangle? Hit pause and try. You should have realized that it is not possible to form a triangle out of 2, 2, and 4. Now try 2, 2, and 3. Could you form a triangle? You should have noticed that yes, you can form a triangle out of 2, 2, and 3. Given 3 side lengths, how can we know if they form a triangle or not without actually attempting to draw the triangle? So I want you to look at everything that you know, what forms a triangle and what does not form a triangle, and I want you to come up with how can I know given the side lengths if it's going to form a triangle or not. The sum of the 2 smallest sides has to be greater than the third side or it will not form a triangle. So practice. Would these side lengths form a triangle? So would 6, 8, and 12 form a triangle? The 2 smallest sides are 6 plus 8, which equals 14, and 14 is greater than 12. So yes, they would form a triangle. Let's look at 3, 4, and 7. The smallest sides are 3 and 4, which equals 7. 7 equals 7, so that's not going to form a triangle. It has to be greater than the third side. The 2 smallest sides out of 2, 5, and 13 are 2 and 5. 2 plus 5 equals 7. 7 is not greater than 13. It is less than 13. So it will not form a triangle. 9, 15, and 22. 9 plus 15 equals 24. And 24 is greater than my third side of 22. So yes, they would form a triangle. Now I need to write 3 side lengths that will form a triangle. Justify your reasoning. Hit pause and write 3 side lengths that will form a triangle. My side lengths that I wrote are 2, 6, and 7. 2 plus 6 is 8, and 8 is greater than my third side of 7. Now I want you to hit pause and write 3 side lengths that will not form a triangle. This time I did 2, 6, and 10. 2 plus 6 equals 8, but 8 is not greater than 10. 8 is less than 10, so that will not form a triangle. Now we're going to look at the angles of a triangle. It says, can any 3 angles form a triangle? Measure the angles of the triangles below. What do you notice about the sum of the angles? Okay, so this is where you're going to need to get out your protractor and you're going to need to measure. A quick review of protractors. You're going to put the center point on the vertex of the angle. Many protractors will contain 2 numbers right here. I don't know if yours does or doesn't, but you need to line it up here and you need to look at this angle and think about, is this going to be an acute or obtuse? This one happens to be exactly a right angle, so this one will be 90 degrees, and I'll do an example where those numbers are not the same. So let's slide over this protractor. I'm going to put it on this angle right there, and this angle is less than 90 degrees. So I'm going to look at this 30, not the 150, because that would be greater. So I'm going to look at 30. So this angle is 30 degrees. And you're going to need to turn your protractor to get it all lined up. So put the vertex, and then one of these lines needs to be lined up with the side of a triangle. So now I'm measuring this angle right here, and which is also acute, so that's going to be 60 degrees. This angle right here, this vertex is an acute angle, and so that's going to be 20 degrees. Slide this over, line it up. This angle right here is obtuse, it's greater than 90. So when I go up here, I'm going to look at the number that's greater than 90, which is 100. Again, I'm going to turn my protractor, and I hope that you're doing this as well with me. Watching me is not going to get a whole lot done. Okay, now take your protractor and line up the vertex here on this vertex. Line up the line with one of the sides, but this is an acute angle, which is less than 90, so that is going to be 60 degrees. Let's measure these angles down here at the bottom. Again, these are acute angles, so the number less than 90, if I look right here, this is right between 70 and 80, so that's going to be 75 degrees. Let's slide it over for the other angle. This is also 75 degrees. And then I need to turn it for this angle up here at the top. Line it up. This is an acute angle, so I'm going to be looking at 30 degrees. What do you notice about the sum of the angles? I want you to hit pause, and I want you to sum up these angles of every triangle. So sum 60 plus 90 plus 30, sum up these three, and then sum up these three, and then write what you notice. Okay, you should have noticed that the sum of all those angles is 180 degrees. The sum of the angles of a triangle will always be 180 degrees. It's not just these triangles. Any triangle angles will sum to 180 degrees. So, could I form a triangle with the angle measurements 30, 40, and 100? Well, if I sum 30 plus 40 plus 100, that equals 170, which is not 180. So no. Could you form a triangle with the angle measurements 35 and 70 and 75? So if I sum 35 plus 70 plus 75, I get 180 degrees. So yes, those angles will form a triangle. Practice. We are going to determine if these angles will form a triangle. 25 plus 60 plus 90. Now, if you want to go through and try this yourself and then come back and check, I think that's a great idea. So I'm going to sum 25 plus 60 plus 90. Summing those together, that gives me 175, which is not 180. So no, those angles will not form a triangle. What about 40 plus 55 plus 85? If I sum those together, that gives me 180. So yes, they will form a triangle. What about 15 plus 65 plus 100? If I sum those together, that is 180. So yes, they will form a triangle. What about 40 plus 60 plus 100? If I sum those together, that gives me 200. That is not 180. They will not form a triangle. So now I want you to write 3 angles that will form a triangle. Hit pause and write 3 angles that will sum to 180 degrees. Okay, I just did 60, 60, and 60. If I add those up, that will equal 180 degrees. Now try writing 3 angles that do not form a triangle. Hit pause and do that now. I wrote down 60, 60, and 20. That is 140, so that will not form a triangle. A triangle is unique if no other triangle has the exact same dimensions or shape. We know that the angles 30, 60, and 90 degrees will form a triangle because they equal 180 degrees. How many different triangles are possible with these angle measurements? I want you to hit pause and I want to see if you can sketch different triangles that have these same angle measurements. All right, you should have drawn different sized triangles, but they kind of look the same. Maybe one is turned or whatever, but they are different sizes, but they kind of have the same look to them. There are actually an infinite amount of triangles with the angles 30, 60, and 90 degrees. 3 angle measurements will never form a unique triangle. You can always replicate the triangle in a different size, so it will not be unique. Any 3 angle measurements, and we write that AAA, so that means you are given 3 angles, will form more than one triangle if they have to sum to 180 degrees. 3 angle measurements AAA, so given 3 angle measurements, will form no triangle if they do not sum to 180 degrees. We know that the side lengths 4, 5, and 6 will form a triangle because 4 plus 5 equals 9, and 9 is greater than 6. How many different triangles are possible with these side lengths? I want you to hit pause and try drawing triangles with the side lengths 4, 5, and 6. Okay, your triangle should look something like this. Were you able to draw more than one triangle? And the answer is no. You should have only been able to draw one type of triangle. So since you were only able to draw one triangle, this is a unique triangle. If you're given 3 side measurements, SSS, they will always form a unique triangle if the sum of the 2 smallest sides is greater than the third side. 3 side measurements, SSS, will never form a triangle if the sum of the 2 smallest sides is less than or equal to the third side. We are given 2 side lengths that form a given angle. So we were given 2 sides and they form an angle in the middle. So we will say side, and then it goes to an angle, and then the other side. Suppose we have 2 side lengths that measure 2 inches and 3 inches. These sides form a 60-degree angle. Are you able to form a triangle with these conditions? Yeah, I can easily just connect that third side. Are you able to form more than one triangle, or do these conditions form a unique triangle? The only triangle possible if I'm given a side and the angle in the middle and then another side, this is the only possibility. I can't do anything else that will form a triangle. So that will be a unique triangle. Given the conditions of 2 side lengths and an angle formed by these side lengths, so that's why it says SAS, because it gives you a side length and then the angle in the middle and then a side. A unique triangle is always possible. The table below is a summary of given conditions of a triangle and whether a unique triangle can be formed. So I'm given 3 side lengths, assuming they can form a triangle, they will be unique. 3 angles, assuming they sum to 180 degrees, but they will not be unique. I can make that bigger or smaller. If I'm giving a side and an angle in the middle and then a side, yes, that will be unique. And if I'm given 2 angles, a side in the middle, and then an angle, that will be unique. 2 angles and then a side that's not in the middle. So the order of these letters matter. This would be side in the middle, so it would be like an angle and then the side in the middle. This would be an angle, and then the side that's not between them. So this would form a unique triangle. And side, angle, it just kind of depends on the numbers. So some of them will be unique and some of them will not. This is just a quick summary. You will go more in depth with this idea of unique triangles in later math classes. Okay, everybody, this is it for today. Thank you.